The seventh question that we have is an important question to know and learn how to analyze data and manipulate data. We have been given a reaction between A and B, and this data is given initial concentrations of A, B for different values of temperature 300 Kelvin and 320 Kelvin. The initial rate of reaction is given. We need to find out the order of reaction with respect to A and B, the rate constant at 300 Kelvin and the pre-exponential factor. Now let us solve the first part. For finding out the order of reaction, let us write the rate of reaction to be equal to K times concentration of A to the power m into concentration of B to the power n. Now let us use these three data given to us. Let us do it for 300 Kelvin since we have three data. 5.0 into 10 raised to minus 4. This will be equal to K times 2.5 into 10 raised to minus 4 to the power m into 3.0 into 10 raised to minus 5 to the power n. Similarly, we will write it down for the second data we have. This is the first experimental data, the second, the third. 4.0 into 10 raised to minus 3. This will be equal to K times 5.0 into 10 raised to minus 4 to the power m and 6.0 into 10 raised to minus 5 to the power n. Similarly, the third data becomes 1.6 into 10 raised to minus 2. This is equal to K times, this is the value of K at 300 Kelvin, 10 raised to minus 3 to the power m and 6.0 into 10 raised to minus 5 to the power n. Now, using this, we will find out the values of m and n. Now, let this be our first, second and third equation. Now, if we analyze second and third equation and divide them, this term is cancelling in division. Therefore, we can write 4.0 upon 1.6 into 10 raised to minus 1 is equal to 5 into 10 raised to minus 4 upon 10 raised to minus 3 to the power m. Now, this is coming out to be 0.25. This is equal to 0.5 raised to power m. Therefore, m is equal to 2. Therefore, we get the value of m to be equal to 2. Now, let us solve for n. Now, we don't find two equations in which you can directly divide so that m terms cancels because these three are all three different. So, let us do one thing. Let us divide the first and the third one to get 5.0 into 10 raised to minus 4 upon 1.6 into 10 raised to minus 2. This is equal to 2.5 into 10 raised to minus 4 upon 10 raised to minus 3 to the power m that we know as 2 into 3.0 into 10 raised to minus 5 upon a upon 6.0 into 10 raised to minus 5, that is half to the power n. So now we can write this as 25 upon 8 into 10 raised to minus 2 is equal to 25 by 4 into 10 raised to minus 2 into 1 by 2 to the power n. Now we see that this is cancelling. This is becoming 2. Therefore, 1 by 2 is equal to 1 by 2 to the power n. Therefore, n is equal to 1. So we get our answer for the first part, that is the order of the reaction with respect to A is 2 and with respect to B is 1. Now let us solve for the second part, that is the rate constant at 300 Kelvin. To find out this rate constant at 300 Kelvin, we take any rate of reaction, any one of these reactions. Since we know the value of m and n, we can find out the rate constant by any one of these equations. Let us use the first equation to get 5.0 into 10 raised to minus 4 is equal to K times 2.5 into 10 raised to minus 4 to the power 2 into 3.0 into 10 raised to minus 5 to the power 1. On solving, we get 5 into 10 raised to minus 4 is equal to K. Let me write this as K1, that is the rate constant at 300 Kelvin. Here we have the rate constant as K1 and let the rate constant here be K2. This is K1 into 25 by 4 into 10 raised to power minus 8 into 3 into 10 raised to power minus 5. On solving this, we get K1 is equal to 4 by 3 into 5 into 10 raised to power 9. This is equal to 2.66 into 10 raised to power 8. Now since this is a third order reaction, therefore the unit will be liter square mole minus 2 second minus 1. Now we need to we have already found out the rate constant at 300 Kelvin. This is our answer for the second part. Let me write it here. 2.66 into 10 raised to power 8 liter square mole minus 2 seconds minus 1. Now we wish to solve the third part. For solving the third part, we must write down the equation K is equal to A times E raised to the power minus EA upon RT. This is what we need to find out. This is known as the pre-exponential factor. Now, to find out this, we can choose a particular temperature because this does not change with temperature. Therefore, let us find it out with 300 Kelvin. We already know the value of K at 300 Kelvin. We know the temperature, we know R. What we now need to find out is the activation energy. If we know the activation energy, we know the pre-exponential factor. Now our aim is to solve for the activation energy. Now, we know a formula for activation energy, which is ln K2 upon K1 is equal to EA upon R into 1 upon T1 minus 1 upon T2. You should also think of this formula because we have two temperatures and two values of K1 and K2. So that is a hint that you should use this formula to find out the value of activation energy. Now for this formula, we know T1, T2, we know K1, but we do not know K2. So our aim now is to find out K2 first, so that we can find out EA and then find out A with the help of EA. Now to find out K2, we have already been given data. This data, first data at 320 Kelvin. Let us use this data. 2.0 into 10 raised to power minus 3 is the rate of reaction initially, is equal to K2, that is the rate constant at 320 Kelvin, into concentration of A to the power m, that is 2.5 into 10 raised to power minus 4 raised to the power 2 into 3.0 into 10 raised to power minus 5 to the power 1. On solving this, we get the value of K2 to be equal to 1.07 into 10 raised to power 9. Again the same unit, liter square mole minus 2 seconds inverse. Now we know the value of K1 and K2, therefore we can find out the value of activation energy by using the formula ln K2 upon K1 is equal to EA upon R 1 upon T1 minus 1 upon T2. Now we have the value of K2 over here, we have the value of K1 over here. On putting these two over here, T1 is 300 Kelvin and T2 is 320 Kelvins. On putting all the values, we get the value of activation energy to be equal to 55.34 into 10 raised to power 3 joules. Now since we have the activation energy now, we'll use it to find out the pre-exponential factor, which is, let us put the value again here. The value of K at 300 Kelvin was 2.66 into 10 raised to power 8. This is equal to A into E raised to the power minus of 55.34 into 10 raised to power 3 upon 8.3, or rather we can write this as 25 by 3 into temperature, that is 300 Kelvin. The exact value of R is not 25 by 3, but we can write it in most of the questions to approximate it. On solving this, we get the value of A to be equal to 1.15 into 10 raised to power 18. Again the same unit as that of K, that is L2 liter square mole minus 2 second inverse. Therefore, final answer for the pre-exponential factor comes out to be equal to 1.15 into 10 raised by 18 liter square mole minus 2 second inverse. So the important formula you should remember is this one, K is equal to E raised to power minus E upon RT, and ln K2 upon K1 is equal to E upon R 1 upon T1 minus 1 upon T2, and you can apply these formulas in combination to find out the final answer.